All right, folks, welcome back. As you know, I'm trying to gather up everybody's emergency contacts so that we can start going out to the farm this week. There's still 3 people who haven't responded. I'm submitting the paperwork without you. I don't know what to do. But if you haven't sent me emergency contacts, do it right now. All right. So we're going to continue our discussion on conventional agriculture. Um, Last time we left off talking about some of the types of grains and silage and all kinds of fun things that we grow within this sector as well as outside of it. So now I'm going to continue that discussion talking about leading field crops on a world production system. So the world grows wheat, rice, corn, soybean, barley, sorghum, and millet, and that accounts for about 75% of world feed crops, but this does not include forage crops. In the United States, we grow corn, wheat, soybean, alfalfa, and sorghum. We have some crops that used to be popular that are declining. Those include buckwheat, syrup, sorghum, cowpea, and broomcorn. Now, you still see these things. It's not like they've just completely disappeared. They're just no longer popular commodities like they used to be. As you drive down the highway, or on back roads, you probably see lots of soybeans and corn, but you probably don't see a lot of broom corn or cowpea or syrup sorghum as much as you see these other items. Former crops that are apparently no longer grown, and I'm going to argue that some of these are coming back, but they just haven't come back yet. Fiber flax, teasel, hemp is making a somewhat of a recovery. It just hasn't actually boomed as an industry yet, but now that it's legal to grow in most states, it is starting to make a comeback, but it has some challenges to overcome before I will take it off of this list. Chicory. So right now, wild chicory flowers are growing, and you probably have them in your yard or somewhere near you. They're little tiny blue flowers. They've got a pretty thick stem, and when you mow them, your mower blades don't actually cut them. They're everywhere right now. All those like blue, lavender, depending on how you see blues. I see them as like a light blue. Um, all those light blue flowers that you see on the side of the highway right now, that's a type of wild chicory. Now, you are not supposed to eat it in large quantities because it can be poison to your system. However, a different varietal of that is what was used in place of coffee during the World Wars because coffee was of limited quantity. So, fun facts. All right, let's talk about agriculture in Indiana because, like, we all live here right now. All right, so about 83% of the land in Indiana is used for farming and forests. Of that, 37,000 acres of vegetables are harvested for sale. The top 5 commodities by value in Indiana are corn, soybeans, hogs and pigs, poultry and eggs, and dairy. Not dairy, dairy. I just dyslexified those letters. About 11.2 billion in agriculture products are sold in Indiana. It's a huge part of our industry, and we're ranked 10th in the nation in agriculture sales. So 10th out of 50. And this is all from 2012 statistics. And I checked them last year to update them. They hadn't changed that much, so I left them how they were. So Indiana agriculture production, we're 10th for total value of agriculture products sold. We're 7th for value of crops, including nursery and greenhouse. And if you haven't gone to Wasan Nursery in Muncie, just go because it's pretty. I like just walking through all of their plants. Absolutely gorgeous. 18th for value of livestock, poultry, and their products. 3rd for layers. 4th for pullets for laying flock replacement. Pullets are like basically baby birds that are more towards getting their feathers. They're not like day old chicks. But, anyways, 24th for broilers and other meat type chickens. Broilers are what we call meat chickens. They're like giant beefcake chickens, if you've ever seen them. And they're bred for that. They're bred for significantly greater meat production, which is why they look so beefy. And there's this type of animal in every type of livestock that we'll talk about. I'll show you examples of cattle that are like this, sheep that are like this. They're all pretty kind of fun to look up. Seventh for turkeys, fifth for hogs and pigs, fifth in the nation for corn and soybeans, sixth for grains, oil seeds, dry beans, and dry peas, and ninth for tobacco. So, ways in which conventional agriculture have increased their productivity. Okay, and this is an exam question. And every time I give this exam every year, people are like, I don't know where to find this information because it's basically a take home exam where you like write essays. And so I'm just highlighting that this is where you find that information. Okay, so we have a collection of plant species and broadening of germplasm bases. We have improved breeding techniques to include the use of biotechnology, crop physiology advances in understanding plant efficiency and utilization of light and nutrients. Interactions between plant breeders, geneticists, soil chemists, engineers, etc., have increasingly brought together the best of many disciplines to progressively make conventional agriculture more productive, more yields per acre. Extension of ideas of adaptation of previously restricted varieties. An example of this is hemp. It used to be restricted, now it's coming back, and we're starting to see people breed it, modify it, make it more of a viable crop. Some of the issues that we're seeing with hemp are that the seeds aren't viable. It's really hard to find a consistent set of varietals because when you get seeds and you're told that it's this, like 12 different varietals will come up because it's technically a new industry that hasn't been legal since like 1860. So hemp is a really good example of where conventional agriculture has had zero increase in productivity for something, and then we brought it back. And since nobody's been doing anything with it for like 100 and something years, almost 200 years, I can't do math. Let's just roll with it. Um, we're seeing people struggle to get it starting again, and so you're really seeing a great example of how science has helped improve other agriculture commodities, whereas that one has stayed stagnant. And they'll improve that one. It's just a matter of like a decade, and you'll see all kinds of cool stuff come out of that. Improved disease and insect control with advances in chemical and biological methods. Improved protein quality factors such as high lysine corn. Improved medication and breeding principles in livestock. Agriculture has a reduced production cost of nitrogen fertilizer. If you guys watched those, all right. All right, conventional agriculture and tillage. So what you'll learn in this class is that tillage isn't good for soil. And I've briefly discussed this with students in other classes, like the intro soils class, we touch on this. But we're gonna go really in depth with the history of tillage so that you really understand where it came from and why it is so hard to get people to change away from it. Okay, so history of tillage, all the way back to 1733, Jethro publishes the Horseshoeing Husbandry in England. Okay, he has like basically, this paper that he publishes, and all the agriculturalists read it and think it's the greatest thing ever. It's 1733. We didn't have blogs. Okay, so we didn't have Facebook either. They didn't have the internet. All right. He believed that plants took up minute soil particles, like legit thought that like roots open up like hungry, hungry hippo, like mouths, like and eat soil particles. Okay, that doesn't happen. That's not real. But he thought that. Okay, it's 1733. Whatever. In other words, the more finely the soil was divided, the more particles he believed would be absorbed by the roots and thus nutrients. Okay, so they're like, oh, in order to grow crops, we have to absolutely pulverize the ever loving life out of our soils. Idiots. So, 19th century, Justus von Liebig and others perpetuate the idea that tillage increases aeration of the soil and increases oxidation of chemical constituents in soils and makes them more available and soluble to plants, okay? And early American writers believed that tillage helped roots penetrate soil easier and helped with weed control. Okay, these are all the ideas that everyone in these timelines believed and thought and just really bought into. So along the same time, a few people are like, I've kind of noticed that excessive tillage, uh, particularly due to greater oxidation of organic matter or from increased erosion, is actually kind of bad. Like there was a few people that were like, wait, I have questions, and everybody else was like, no, you're an idiot, sit down and shut up. Okay. So there were a few people that were like, I noticed that like your field is losing all of its topsoil and like rills are forming and there's gullies and like maybe you shouldn't do it that much. But everybody else was like, nah, till all the things, okay? Because it's wonderful and the plants are giant, crazy mouths. Like, remember the old school Mario games with the big, scary plants that like eat people? Like, is that what they thought their roots were like? I don't know. Let's just imagine that for a second. Yeah, no, they're still stupid. Okay, moving on. All right, conventional agriculture ultimately decided that the purposes of tillage were to prepare a suitable seedbed, and it's not wrong. Soil to seed contact is very important for germination, and tillage does make that easier. Okay? They also felt that tillage eliminates competition from weed growth, and that is actually not true. It makes it worse. Weeds are just like specifically designed by nature to pioneer areas of disturbance. So they're actually making their weed problem worse. To whoops. Anyways, they thought that it would improve the physical condition of soils. Newsflash, it doesn't. Tillage can incorporate manure or crop residue, and this is true. Okay, so I will say that even in no-till operations, if you are like really heavily cover cropping and you have a lot of residue on the ground, you make yourself more susceptible to certain like mildews and fungal issues. And so sometimes some of the northern or some of our Illinoisan friends will come through like once a decade and help incorporate some of the like buildup of residues. But that's, you know, not everywhere that has to do that. So and also, if you are land applying manure, you are legally required to incorporate it via tillage so that it doesn't run off of the surface of the soil. So there are some instances where we do still have to till, and it's not necessarily a bad thing. Um, but the whole like 1733 pulverize it all to crap to save the world, not the best idea. So, you know, some more sustainable practices are to till only in row if you need to, or till only, you know, when you do major manure applications, or, you know, every couple years if you absolutely have to help break up some, like really high lignin cellulose surface residue that just isn't breaking down. Okay, but ultimately, the most sustainable version of all of this is to do no-till. And there's lots of people who figured out how to do it successfully. And so, you know, we're just still trying to get farmers to buy into this. But the other part of this is no-till instruments are really, really expensive. So I don't want you to like hate on farmers who are still tilling because they could they could be working towards a no-till operation, but like implements are not cheap. Like the student farm still doesn't have a no-till drill because it's like a lot of money, so much money. Okay, like farmers spend like $500,000 buying like a tractor and seeder setup, and sometimes it's closer to $1 million depending on how big you need to go. I mean, if you're farming thousands of acres, your equipment's going to be really expensive because you are going to be using the biggest of the big. And it's not cheap. If you've ever seen these tractors, like you could live in them. They're amazing. Anyways, um, so the other part of this is money. Like it takes time and money, honey. All right. So it just we got to give them a little grace, but they've got about like 15 more years until we're gonna be angry. All right. Pest control practices in conventional agriculture. So in conventional agriculture, chemical pesticides are not the only way to control diseases. So everybody always thinks that all conventional agriculture does is spray stuff to kill it, and that's not true. There's a lot of other things they employ. Um, and I say all this to kind of prepare you for some of the more sustainable alternatives. Okay, so stay with me here. We've been breeding crops for resistance to diseases since 1890. Okay, and that doesn't mean that in 1890 they were like taking a syringe and inserting genes. Okay, it means that they were like, hey, this plant didn't get eaten by grasshoppers this year, so I'm going to take seeds from it for next year. Okay, like selectively choosing, uh, varietals for slow bit, like you learned about Mendel's peas, right? Like he grew all these peas and like crossbred them and like made them into a varietal of strains. It's the same kind of thing. They basically like chose the ones they wanted that seemed to do better, like survival of the fittest. All right. So selection and breeding for resistance to insects has been in progress for about 80 years. So we're making progress without like doing scary things. Sex attractants were being developed to permit sterilization of male insects by radiation. I personally don't necessarily think this is the most sustainable because like insects are kind of important for other layers of ecology, but this is something that they did, and we'll talk about why. So other attractants are used as baits for trapping insects. So I've actually seen this done. What they do is they put these little traps on the edges of fields and they put like little like hormone capsules to attract what they want to see just to see if it's in the field. So if they see that they have a significant population of Japanese beetles, then they'll spray for them. But if they don't see anything, then they don't spray. So the whole idea here is why spray if you don't have a problem? So basically, they're looking to see in these little traps if they even need to spray. And a lot of times they don't need to. And so that's helped the industry save in pesticide use as well. Natural enemies of insect pests and disease organisms and viruses may help to control some pests. So, this is where the idea of nature fighting your battles for you. Natural defenses are being employed into existing hybrids and cultivars using biotechnology. All right, so this is where they are literally taking genes from something and inserting into something else, or taking genes from the same strain but that have developed, more resistance, and putting it back in this same kind of strain. So these are just a few of the efforts made to replace pesticides. And I get that you might not be comfortable with all of them for a variety of purposes. I just providing all the conventional background for educational purposes. Don't shoot the messenger. So why do we care about pests and crop production? So ultimately, yield reduction from biological sources alone is estimated about 30% or more of the potential yield. Okay, so here's what I want you to imagine. Like, you probably already aren't making a lot of money being a college student, and like most college students are working part-time jobs that pay minimum wage or barely a little more. And like money is rough. I get it. I'll never forget how poor I was as a student. Yeah, anyway, so I want you to take the meager bit that you are getting, and I want you to just take 30% out of it and just throw it in the trash can. Just be like, bye. I'm gonna go feed you to some grasshoppers. And would you just continue doing that? Like, if you had like this wild, crazy, smart population of grasshoppers who like knew your ATM code and just took 30% of your money every year, would you every month or every 2 weeks or however? There we go. Why control pests? Crop production is goal oriented, and ultimately it's a business. And as a business, they need to make money. And producers deliberately control pests to favor the crop being grown for maximum productivity. Okay, pests are never fully eliminated, we know that, but rather reduced to a population where they cause no economic loss. Okay, so we know that about 10% of what we grow every year, we're basically going to lose to pests, and that's okay. That's an economically viable percentage. Above that is where we start seeing problems. So pests include crop diseases, bacteria, virus, etc. It's not always a bug. Sometimes it's a macro or a microorganism that you can't see with the naked eye. Insects, parasitic plants. They're actually plants that eat other plants. So maybe the Mario Brothers game like wasn't so off base. Just saying. There's nematodes and worms that live in the ground, and they are carnivores for root systems and seeds. Weeds can take over fields. Like this year, Water hemp has been a huge issue in soybean fields because we haven't found anything to kill it. And so it's just taking over. And it looks like, people are basically growing like this weird weed alongside their soybeans. And not much we can do about it yet. We'll figure it out eventually, but right now it's causing huge yield losses. At the farm, if you saw all of those weeds growing in the soybean fields, that's water hemp, and it's causing a huge issue. Vertebrates, mites, all of these things, contribute to yield losses. Now, that doesn't mean that they can't coexist with us. It doesn't mean that we have to wipe all of them out. There's still a small percentage that we account for to lose. It's when we get a concentration in a large population that outbreaks in a field, that's when it becomes a problem. So some methods of pest management in conventional agriculture. And for those of you who are like, I hate all of this, they're killing the world. Don't worry, we're going to get to the sustainable ones. But right now we're talking about conventional agriculture, so hang in there. All right, so the first thing is probably going to make you feel a little warm and fuzzy if you're more on the sustainable side already. Biological pest management. Use biology to our strength, right? The use of one organism to manage the population of another. Parasitism and predation, natural life cycles. All right, so we have an outbreak of squash beetles. All right, I forget the name of the bug that eats them. Whatever, bad example. Moving on. How about we have an outbreak of tomato hornworm? Okay, well, let's bring in some braconid wasps. They're going to lay their eggs on the back of the tomato hornworm, and their eggs legitimately eat them alive and then hatch and fly off. How gross is that? Nasty. Hope you're not having breakfast right now. Sorry if you are. Delicious. Worms getting eaten by wasp babies growing out of their back. Anyways, cultural pest management includes crop rotation. Just rotating something as simple as corn and soybeans every year cuts down pest management tenfold. We are using way less pesticides than we've ever used before, just using that alone. Not growing the same thing in the same field year after year after year after year. Sanitation of equipment, planting equipment, harvesting equipment helps to decrease fungus and molds, etc. Resistant cultivars, using genetics to our advantage. Okay, like some of us have better genetics than other. Like I have no immune system, basically it's worthless, and I get everything all the time from my children, so my genetics are retarded. I am not a resistant cultivar at all. Struggle is real. Anytime somebody comes to my class with like a cold or a sneeze or a sniffle or like their eye twitches, I'm like, I'm gonna get it. It's happening. Here it comes. Might as well get ready. Take my zinc. Doesn't help. Anyways, mulching also helps decrease weed growth because it increases the carbon to nitrogen ratio. Host eradication. Okay, so if we know that they're hosted by a certain thing, eradicate the thing that hosts them. They don't have a house. Toodaloo. All right, planting date can make a huge difference. So this is a part of the Farmer's Almanac and why so many farmers live and die by it, because there's certain planting dates that are better than others that we've noticed over time. Like, I forget the statistic, but something like people who plant on May 30th are blank percentage likely to have this versus this yield. Like little things like that we've like collected over, 200 something years of being, you know, civilized humans that have collected agriculture information. Anyways, soil reaction, just managing pH can change the likelihood of getting fungus, molds, etc. Certain bacteria only live at certain pHs. So, really easy way to control fungus and mold, increase the pH to like 6, 6.5. They prefer acidic soils. Once you get into the range of like 6 to 7, they're pretty much out. Bye. Improving drainage. Okay, so that's why, especially in Indiana, we have really high water table, lots of rain. We put in tile drainage, and that helps to manage issues associated with too much water, like molds and fungus, etc. Less crop density helps immensely. So wider spacing just gives the plants more area to breathe. It allows them to get better established root systems. They're not over competing for nutrients, and they end up doing better. It's like the same thing as humans. The more closer packed we are, the sicker we are. It's the way it is. It's the way it is. That's a song that I can't remember the rest of. Anyways, legislative pest management. When we bring plants from other areas, they have to be quarantined and inspected by the state. This is why anytime you travel anywhere, they make you like quantify what you are bringing back with you. Like if you fly to Hawaii, you have to fill out a customs form like saying, "No, I don't have a palm tree in my luggage." Not that you could fit one in there, but if you could, you'd probably try and they'd catch you. So anyways, physical mechanical pest management using mechanical traps, hand picking them off, using actual physical barriers like nets, that kind of thing, which is really popular in the berry industry to keep birds from eating them, basically. Uh, Tillage is not the best thing, but it can sometimes maybe be used. I don't like it. Anyways, heat treatment. So one of the most popular ways to kill weed seeds is to cover the soil in black tarp. Uh, so basically, you wet it down and get it nice and soaked, and then you cover it in black tarp at like when it's really, really freaking hot at the beginning of the year and beginning of the growing year, I say. And it basically heats up under that tarp. Your goal is to get it to like 120 degrees, and it'll kill everything. Sometimes, if you don't want to get it super, super hot, if you're not trying to solarize it, basically, you can just cover it with clear plastic. And what happens is all the weed seeds germinate and then they die. See? Sadistic, but it works. Okay, chemical pest management. Uh, this is the last resort in conventional agriculture because it's the most expensive. Okay? Pesticides. You spray it and it's dead. And in order to spray pesticides, you have to go through a whole training and licensure. Like the least amount of training is people who are spraying their own pesticides at home. And actually, studies are showing that that's the biggest contributor of a problem. Actually, even less so than agriculture, which is kind of crazy. All right, pest management, chemical, moving into the things that'll kill you. So our target pest are, we're going to talk about the general classification of pesticides, okay? Because in order to learn about what is more sustainable, you have to really understand what's in conventional. So first of all, the general classification is based on the target pest, okay? Those that manage unwanted plants and those that manage unwanted animals, all right? So herbicides manage unwanted plants, aka anything that's an unwanted plant is a weed, okay? When you're growing soybeans, any corn plants that pop up are considered weeds. Management of unwanted animals are classified to reflect the category of the animal. So insecticides are used for insects. Fungicides are used for fungi. Nematicides are used for nematodes. Rodenticides are used for rodents. Molluscides are used for mollusks. Miticides are used for mites. Aviicides are used for birds. Bactericides are used for bacteria. Make sure there's nothing up in the comments. Okay. Herbicides, which are pesticides classified for weed control. We can use them for pre-emergence, meaning we spray them before the appearance of the weed so it can never get started. Post-emergence, meaning we walk out in our field, we're scouting it, we see that water hemp is coming up, so we spray it and try to kill it before it takes over. Defoliants are used to cause premature leaf drop to facilitate harvesting. Okay, so we can actually, if we're growing wheat and we're like, oh man, we need to get this thing going before the rains come in or bad weather comes in, we had to plant late, blah, blah, blah. Or maybe it's drying at an uneven rate or blossoming at an uneven rate in the field. We can spray it with a defoliant and it causes premature leaf drop and it causes the plants to all die at the same time so that we can have more efficient harvesting. Desiccants are used to prevent pre-harvest drying of plants that do not normally shed their leaves, or drying of actively growing plant parts when seed or other plant parts are developed but only partially mature. So again, same kind of thing. So pesticides are also used to manage animals, okay? So insects are managed using insecticides. Those used to manage vertebrate pests like small animals, large animals, birds, and reptiles. And we also have pesticides to manage pathogens which cause diseases. like fungi, bacteria, viruses, mycoplasmas, and nematodes. So when we are classifying pesticides, we also have to look at the type of material being used. There's some that are developed from natural products isolated from plants like pyrethrum or nicotine, or from living organisms, and these are what we use in the organic industry. Okay, so for those of you who think that when you buy organic produce that it did not get sprayed with pesticides, it still gets sprayed with pesticides. They're just pesticides that are isolated from a living plant or organism. There's also pesticides that are developed from synthetic products or artificial compounds, and these are not allowed in organic production but are used in conventional agriculture. So the chemical structure of the compound also plays a role in the classification of the pesticide. Based on active ingredient responsible for killing the action of the pesticide, these may be classified as organic or inorganic. Okay, so inorganic are on the decline, like the Bordeaux mixture. These are the really scary ones, like not the best. That's why they're like, don't use those anymore. We're all gonna die. Arm's gonna grow out my head. Like, although that would honestly be a little useful to have a third arm, even if it was growing out of my face. Organic or botanicals derived from plants are on the rise, like pyrethrum, nicotine, retinone. Synthetic organic compounds are effective against a wide variety of insects and other pests. That's why they're so widely used, because they're effective. Organochlorines are chlorinated hydrocarbons, are their active ingredient, and they're not readily biodegradable and persist in the food chain. And we're trying to move away from these because they're terrifying. DDT is a really popular example of something that we no longer use in the United States, but it's still used across the world, okay, which means it is still accumulating in the food chain elsewhere. Organophosphates have shorter residual action in the environment and are safer to use. So examples of these are malathion and diazinon. Organic pesticides are more selective and pose less danger. So examples of these are like carbamates. Carbaryl is an example of this. Formamidines. Amitraz is an example of this. Organotins. Phenbutetin is an example of this. Biologicals like living organisms such as Bacillus um, thuringiensis spores. This is really common, BT. It's used really like very, very large quantities in both conventional and in organic agriculture. And pyrethroids, which are synthetic pyrethins, such as permethrin. Okay, so they basically synthetically create something that's a lot like the plant-derived permethrins. So there's a synthetic version and there's a natural version. Mode of entry and action is another classification of pesticides. Okay, so pesticides kill pests in a variety of ways. They can kill them through contact, like literally kills on physical contact. An example of this is Captain. Stomach action, which is like the worst possible way, I think. Stomach poison kills upon ingestion. Systemic action, once ingested, it moves through the entire organism. An example is Benomil. Repellent action, so it doesn't kill them, it just repels them with strong odors. Sulfur is a big example of this. Cinnamon is an example of this. Fumigants attack the respiratory system of the target. Formulation could be an aerosol that's sprayed. It can be a flowable that again would be poured or sprayed. Fumigants, which is fumigated. Dry formulations. There's granules, there's dust, there's wettable powders. I mean, they come in all shapes and sizes. So now we're going to talk about the general classification of herbicides, which are for plants specifically. Okay, so the first are contact herbicides like diquat or paraquat. There's also growth regulators like 2,4-D dicamba. There's photosynthetic inhibitors like diquat, paraquat, and atrazine. Pigment inhibitors like block formation of keratin and chloroplasts. They usually cause the leaves to bleach out, and then they're unable to perform photosynthesis and the plant dies. Meristemic inhibitors. Meristems are the growing part of plants, and trifluralin, for example, will inhibit root growth and development. There's enzyme pathway inhibitors, which will block key steps in the metabolic pathways in plants by targeting specific enzymes. So I'm going to insert right here a opinion. Okay, so this is, you do not have to take on my opinion. This is just, like I'm saying, my opinion. Okay, there's been a lot of stuff in the media about glyphosate. I'd like to tell you that there is zero scientific evidence showing glyphosate can harm humans. The enzyme pathways for plants are completely different than the enzyme pathways for humans. We literally have none of the same things. Okay, so I know that there's been a lot of people who have been celebrating some of the victories of people getting um, payouts because they've been exposed to glyphosate throughout their career. But as a scientist, I'd like to know what else they were working with, because no pesticide spray use in either a commercial or agriculture environment, commercial meaning like landscaping around professional buildings, schools, campuses, that kind of thing. No one uses just one thing. And so I don't understand how these cases are being won because glyphosate only kills plant pathways. We're not plants. We don't have chloroplasts. We don't use uh, photosynthesis. So I don't understand how when there's zero scientific evidence to show that glyphosate does anything to people, that people are getting all this money. And don't get me wrong, like if I mean, there's people who are really, really sick. They've gotten crazy cancers. But I'm telling you, it's not from glyphosate. It's from one of the other things that they were working with, but it's impossible to prove which one it would be. So don't get me wrong. I don't think that pesticides should be used on a grand scale. I think some of them are very dangerous and I would never ever use them. But I don't see how glyphosate is dangerous. Okay, so when I talk about scientific studies, I mean something other than the company, something other than the company who made it. Scientists actually studied it in a controlled environment and wrote a published peer-reviewed paper. And nothing other than like Mother Earth blog posts have found that glyphosate can do anything. And I'm sorry, but Mother Earth blog posts are not a source of scientific information. Okay, that's all my opinion. I'm moving on. And I encourage you all, when we get to the part of the class where we are going to start having debates, some of those debates are going to include conversations about that. And if you find something to prove me wrong, I will be excited to read it. Honestly, I really will. Because I'm always looking for information to prove myself wrong, always, because that's the way you should be. You should be objective and open-minded. So if there's a study that comes out this year or last year that I haven't seen, or even one that I missed somewhere along the way, I would be excited to read it and to have myself proven wrong. Okay, fertilizing and nutrient management. Fertilizers are applied to the soil to promote greater plant growth and better crop quality. This is usually based off of a soil test showing a need for nutrients, nitrogen, phosphorus, and potassium, and the three most commonly fertilized are nitrogen, phosphorus, and potassium. Nitrogen is used in the most quantity, followed by phosphorus. More than a century ago, Justice von Liebig proposed that what is removed in crops should be replenished in soils because, I mean, think about it. The nutrients grow into the plant, and then we remove the whole plant, and none of the residue is left to degrade back and provide the cycle of those nutrients back into the soil. So we also have issues, and we're going to talk a lot about this in this class, with excess nutrients. Okay, this is a huge environmental issue that agriculturalists have been addressing since the 70s when it first came about, but more needs to be done, and that we are constantly trying to come up with new ways to make this work. So eutrophication, drinking water hazards are just some of the small issues that have been brought up. Okay, so eutrophication occurs when excess amounts of nitrogen and phosphorus enter surface waters because, usually this is due to poor field management, but it's also, there's a huge contribution coming from commercial fertilizer use outside of agriculture, as well as what people are spraying on their lawns, as well as what's coming off of golf courses, none of which have been studied or quantified extensively until recently, and it's playing a much bigger role than we ever imagined. Not to say that agriculture is off the hook, because we're a big problem too. So uh, all of those sediments that come off of fields via erosion, no naked soils, remember that theory, um, they cause algal blooms. And as the algal blooms die, the microorganisms that degrade them suck up all the oxygen out of the water, and it causes massive fish kills. Another issue with poor nutrient management is excess amounts of nitrogen get into groundwater. Now, I live rurally and I drink out of a well. I'm surrounded by fields. I get my well tested all the time to make sure that it doesn't have excess amounts of nitrogen or excess amounts of any of the chloroforms or bacteria associated with excess agriculture use of manure. So, um, long story short, if too much nitrogen is in groundwater, it turns into nitrite, and nitrite can displace your blood vessel's ability to transport oxygen. Okay, and this is especially negative for babies, and it causes methylglobulinemia, which is blue baby syndrome. And you can see this adorable baby is actually turning blue because it's not getting enough oxygen through its system, because mom was likely on well water.